In this lesson, we're going to talk about atoms versus ions. We're going to introduce this idea of what an ion is, and we're also going to draw some Bohr diagrams for ions and learn the rules for naming ions. Ions are formed when an atom either gains or loses electrons. We can have negative ions. We call these anions, and I'm going to be using the color blue for negative ions. Or we can have positive ions, which we call cations. Why do ions form in the first place? When atoms form ions, the ions have the same number of electrons as the nearest noble gases, which means they have a full outer energy level. That's already bolded, but I'm going to highlight it. The reason why they form those is because the ion is more stable or less reactive than the original atom. We want to have a full outer energy level. Another word for this is we have a full valence shell. You might be referred to as having a full valence shell. For atoms in the second and third period, this is going to mean 8 electrons. If we take a look down here, there are 2 ways that atoms can get their outermost energy level to have a full valence shell. They can form cations or they can form anions. Cations are our positive ions. I remember that cations are the positive ions because I like cats. I look at the word cat and I think cats are cute. That's a positive thing for me. I like them, and so I remember that cats are our positive ion because they are adorable. And here is a poor drawing of a cat to represent my love for the cations. Marvelous. Cations have lost electrons. Remember that electrons have a negative charge. That's important, so I want to make sure I write that here. I'm going to write that actually as another bullet point here, and I'm going to say electrons have a negative charge. What that means is that if you gain an electron, you're going to become more negative. If you lose an electron, you will become less negative, or you will become positive. All metals form cations. All metals form cations. And if you've been looking at your periodic table, you'll see that a lot of them have, and I'm going to zoom in on this sodium one here. They have this little positive charge underneath. That's very blurry, but it says Na+, and if you have your table in front of you, you'll see that this is a metal, and it's a cation. It's got that positive charge. Negative ions are called anions. Negative ions are called anions. I think that the word anion kind of sounds like onion, and onions make me cry, and that's sometimes a negative thing, and so then I remember that anions are negative. They become negative because anions have gained electrons. Most non-metals form anions. There are a few non-metals that don't really react. They don't really form ions. They react, but they don't really form ions, like carbon and silicon, and most others, though, they form anions, and you'll see those on your periodic table with the negative charge next to them. You're taking a look here. This is what's happening when a cation forms. This is the sodium atom. This refers to the electron configuration in the bottom here. It's got 2 electrons in the first energy level, 8 electrons in the second energy level, and just 1 electron in the final energy level, the third one. Sodium wants to have a full outer energy level. Now, the only way to do that is to gain 7 electrons or to get rid of this one, and then it's left with a full energy shell. So what sodium is going to do is it's going to take this electron and it's going to get rid of it. So you have lost an electron. Remember that a sodium atom has 11 protons in its nucleus. This atom has 11 protons and it has 11 electrons. But when it loses this 1 electron, the sodium ion has 11 it's lost an electron, so it has 10 electrons, but it still has 11 protons. Because you have more protons than electrons, and these protons are positively charged, the sodium ion overall has a +1 charge. Because you have 1 more proton than you do electrons, you overall have a +1 charge. I'm going to put a little note here. You have a positive charge from having more protons than electrons. Please note, electrons are the only thing that move. Protons never move. We haven't gained a proton to become a positively charged ion. We have lost an electron. Moving over to the anion box here. Anions have gained electrons. Most nonmetals form anions. This is oxygen here. So if we're looking at oxygen, the oxygen atom, this is our configuration, has 2 electrons in the first energy shell and 6 in the next energy shell. It wants to have a full outer energy shell. Oxygen could either lose all 6 of these or gain 2. It's much easier for oxygen to gain 2 electrons and then fill up its outer energy shell. This forms this oxide anion, where these 2 electrons have now been added. Remember that an oxygen atom, which has atomic number 8, will have 8 protons in its nucleus. The oxide ion also has 8 protons in its nucleus. However, the oxygen atom has 8 electrons, whereas the oxide ion has 10 electrons. Just like the sodium ion was positively charged from having more protons than electrons, the oxide ion is negatively charged from having more electrons than protons. I'll write that here. And not only that, it's a 2- charge because we have 2 more electrons than we have protons. We have a negative charge from having 2 more electrons than protons. The negative charge comes from having 2 more electrons than protons. Okay, we're going to draw a couple of Bohr diagrams to show this shift. But I need to make an important note, and I'm going to put that down underneath this chart. Only electrons move when forming ions. Proton and neutrons. I'm going to say proton and neutron number remains the same. So we're going to take a look here. We're going to draw some Bohr diagrams. We're going to start with the sodium ion. I'm going to zoom in on that over here. Starting with our sodium ion. We'll make our nucleus. Sodium's got the atomic number 11, so it's got 11 protons in there. And then if we take our atomic mass, 23, subtract our atomic number 11, we've got 12 neutrons in this nucleus. We've got 11 electrons to place. For sodium, we can put 2 in the first energy level. We can put 8 in the second. And that leaves us with 1 to put in the third energy level. When we form the sodium ion, so this will be our sodium atom. I'm just going to write underneath. This is the sodium atom. When we form our sodium ion, our valence electron leaves. So now we're going to lose our valence electron. The Bohr diagram for the sodium ion is very similar to that of the atom because the nucleus is the same, but we are going to change our number of electrons. So when we're drawing this, now we've got 2 electrons in that first energy level, 8 electrons in the second, and we've got nothing in the third. You can draw an empty one. I'm just going to erase it. There's just nothing in the third energy level. Overall, this Bohr diagram has a positive charge. This is for a sodium ion, which will have the symbol Na+. We'll look at another metal just below here. We're going to look at a magnesium ion. So we're going to draw the Bohr diagram for magnesium. Magnesium will make our nucleus. It's got the atomic number of 12. So that means it has 12 protons. Its atomic mass is 24.31, so we'll round it to 24. We'll subtract our atomic number, and that will get us 12 neutrons. 12 protons, 12 neutrons. It's also going to mean that we have 12 electrons to place. We can put 2 of them in the first level. We can put 8 in the second. We still have 2 left over to put in the third energy level. Now, magnesium is not going to just lose 1 electron. Magnesium wants to have a full outer level. So when magnesium forms an ion, it's going to get rid of both of these valence electrons. You can predict what the ion's going to form by looking at your periodic table. You can see that magnesium has this 2+ charge, which means we must have lost both electrons. So we will lose both valence electrons. When we draw our magnesium ion, we'll make our nucleus. It stays the same. But now we've lost those valence electrons, so the magnesium ion has the same electron configuration as the sodium ion. The sodium ion here has 2 electrons in the first energy level and 8 electrons in the second. The magnesium ion has the same electron configuration. It doesn't have the same nucleus though, because the magnesium ion has 12 protons in the nucleus and 10 electrons orbiting, which means it has an overall 2+ charge. This is our magnesium ion. And we put a little 2+ superscript to show that it's charged, whereas this is for a magnesium atom. Note that when we're going from the atom to the ion, the only thing that changes is the electrons. The nucleus stays the same. This would be a 2+ cation. This would be a 1+ cation. We just put a single plus. We don't put a 1 when it's got a charge of 1. So this sodium's just got a plus on your periodic table, but the magnesium has a 2+. These are cations. Let's take a look at anions. Look at the side. We're going to start with chlorine, and then your periodic table helpfully gives you the name of the anions. So this chlorine is going to form the chloride anion, but we'll start with chlorine. Let's make our Bohr diagram for a chlorine atom. Chlorine's got 17 protons. It has 18 neutrons. I'll let you do the math on that. And we've got 17 electrons to place. Let's put 2 of them in the first energy level, 8 of them in the next. That's 10. So 7 electrons on the top. Chlorine is not going to want to lose all 7 electrons. It just needs 1 more in order to fill its outermost energy level. And so we will instead bring in an electron to make our chloride ion. So our chloride ion, our nucleus stays the same. It has not changed. It's got 17 protons still, and it has 18 neutrons. But now when we make our energy levels, we have added an extra electron to the top. So our third energy level is filled, which is why we make an ion in the first place, to have the valence energy level filled. Overall, we're going to have 18 electrons, but 17 protons, so we have a negative charge. Your Bohr diagrams for ions should always have the outermost energy level filled. For sodium, the outermost energy level is filled full 8. For chlorine, same thing. However, for sodium, we filled this by getting rid of, well, this was already full, but we made it our outermost energy level by getting rid of this 1 valence electron, whereas for chlorine, we have filled our outermost energy level by gaining an electron. Let's look at oxygen, which is going to form the oxide ion. We'll make our nucleus. It has 8 protons. 16 minus 8 would give us 8 neutrons. We'll put 2 of our 8 electrons in the first energy level, which leaves us 6 to put in the second. When we become an ion, we want to fill this energy level. It'd be easier to gain 2 than it is to lose 6. So when we turn oxygen into an anion, our nucleus stays exactly the same. But now we'll fill our outer energy level. If you're counting up electrons, we've got 8 plus 2, that's 10 electrons, but 8 protons. So we have more negative charges than positive charges. So overall, we have a 2 negative charge. This is the oxide ion versus this is the oxygen atom. There's some good practice on the next page. I'd encourage you to take a look at doing some more Bohr diagram drawings, but I'm just going to look at some of these questions with you right now. I'm going to look at 1 and 2 here. A particle has 20 protons, 20 neutrons, and 18 electrons. is this an atom or is this an ion? Well, if the proton number equals the electron number, then you have an atom. But if it doesn't equal, then you have an ion. I'm going to put that as a note here. So I'm going to say if the number of protons equals the number of electrons, then it is an atom. We can build on this. For this particular example, for number 1, if the number of protons is greater than the number of electrons, then it is a cation. Which, remember, I like cats, so that's positive ion. So if we're looking here, we've got 20 protons and 18 electrons, which means this is an ion. I have more protons than electrons. I, in fact, have 2 more protons than electrons, so my charge is going to be 2 plus. To figure out which symbol I use, I look for the proton number. Remember that the proton number is always equal to the atomic number. The number of protons equals the atomic number. The number of electrons can change to form an ion, but then if we take a look, number 20 is calcium. Number 20 is calcium. The symbol we'll use here is going to be the symbol for calcium, but we'll give it a 2 plus charge. If you look at the next one, a particle has 13 protons, 14 neutrons, 13 electrons. The number of protons and the number of electrons is the same, so this is going to be an atom. Atoms have no charge. The charge on the particle is 0, or you can write no charge. The symbol for the particle, find atomic number 13, which is aluminum. So our symbol is going to be Al. You don't need any charge on it because it's an atom. We don't put a little 0, it's just Al. Let's do number 3. A particle has 15 protons, 16 neutrons, and 18 electrons. Well, we already said that if the number of protons equals the number of electrons, then you have an atom. If the number of protons is greater than the number of electrons, it's a cation. Well, there's another possibility. If the number of electrons is greater than the number of protons, then it's an anion. Remember, anions are negatively charged because the word anion sounds like onion, and onions make me cry. This is an anion because I have 18 electrons and 15 protons. I have more electrons than protons, so this is an ion. The charge on this particle, I can subtract the number of protons I have. Or if you like maybe you don't like integers, but integers are the best way of thinking about this. Think of it as a positive 15 plus a negative 18, which overall is going to give me a charge of negative 3. We write that as 3 minus. What's the symbol for this particle? Well, we know that the atomic number is 15, so if we go to our table, the atomic number 15 is phosphorus. So we'll put in the P for phosphorus. But this is the ion form, which is called phosphide. and it's going to be P3 minus. You could do the same integer math over here for this calcium ion, where if you took a positive 20 and you added it to a negative 18, you would end up with a charge of positive 2. You can actually do the exact same integer math for the aluminum atom, which had a positive 13 plus a negative 13 would give us an overall charge of 0. Go ahead and try 4 on your own. And this is similar to the Bohr diagram periodic table, abbreviated periodic table that we had for atoms. I would encourage you to try it out. What you're going to notice is that the electron configuration for a lot of these is the same. The electron configuration for a lot of these is the same. Some of these don't form ions. You can actually cross out, I'll do it as a big purple X. You can cross out boron, you can cross out carbon, and you can cross out silicon. Those ones aren't going to form ions. Naming ions. Cations, which are our positively charged ions, are named with their full name, and then we just add the word ion on the end. Again, I'll be using red for cations. For example, Na plus is simply called the sodium, is called a sodium ion. It doesn't have any change to the name sodium, it's just the sodium ion. If sodium became a positively charged ion, it had to have lost electrons. Most metals in general lose electrons to form cations. Remember, electrons are negatively charged. Anions, which I'll use blue for, are negatively charged. We name these by removing the suffix "ine" and adding the suffix "ide." We change it to "ide." For example, Cl- is called a chloride ion. Cl- is called a chloride ion. And if it's forming a negative ion, it had to have gained electrons. Because electrons are negatively charged, the chlorine must have gained an electron to form a negative ion. There are other types of ions called multivalent ions and polyatomic ions that we will discuss later when we talk about ionic compounds. For now, here is a helpful chart that you can do some practice with. The fluoride ion gets the symbol F-. It has 9 protons, 10 electrons, and when it became the ion, it gained 1 electron. If you kind of work through this, then you can get some information down there. Not everything in here has to be an ion. It could have an atom as well if you wanted. But we can make the ion that's formed by number 53. So find number 53. Number 53 here is iodine. On my periodic table, it tells me that it has a 1 negative charge. Your periodic table, I think, straight up says iodide on the bottom for Science 10. But when it forms the ion, it's going to be called an iodide ion. And we'll have the symbol I-. It's got 53 protons. If it's got a negative charge, it must have gained an electron to have more electrons than protons. So it gained 1 electron. We'll do just an example of a positive ion. If you took like take a look down here. This one we haven't looked at before. Sr2+, it's going to have the same name as the normal element. We'll just put the name ion after it. You can find Sr is strontium, number 38. Strontium, so this Sr2+ is going to be a strontium ion. And the number of protons is just the atomic number. So strontium is atomic number 38. It will have 38 protons. And the number of electrons, if it's a positive ion, then it should be less than the atomic number by the charge. So this is a positive ion by 2+, which means you have 2 less electrons. So strontium should have 36 electrons because it lost 2 electrons. That's how it got its 2+ charge. Compare that to iodide up here, which has a negative charge, so it must have more electrons than protons. That's all for today. I would encourage you to practice filling out this table because your knowledge on ions is going to come in handy when we get to naming ionic compounds.